So today we learn a very important topic, that is Carnot cycle. So you all aware heat engines. Heat engine is of two types. One is internal combustion engine. The other one is external combustion engine. So internal combustion engine means your automobile, your car you take. So in the car, what happens? There is a combustion chamber. In the combustion chamber, there will be fuel vapor. There may be diesel vapor or a gasoline vapor. Gasoline means petrol. So, and it gets mixed up with the air and it burns there and it creates, and that energy will be converted into mechanical energy, right? So that is what is the internal combustion engine. There is another engine called external combustion engine, railways. So that is outside the cylinder, fuel will be burned. So, and steam will be generated. That will push. So that will give the energy, the system. So there are two types of engines, right? So internal combustion engine and external combustion engine. So this Carnot is a scientist. Completely his explanation is hypothetical. He has not created any engine. He has not even made a pilot engine also. He has not made anything.
Imaginary.
So just is pure imagination. Simply he has given the theory. Okay, it has become very famous. So let us see. So his basically his Carnot cycle consists of four steps. One is isothermal expansion. Isothermal expansion. This is the first step. Isothermal expansion is the first step. So in the piston, I'll explain. First, you just see the steps. So stage 1 is isothermal expansion. Stage 2 is adiabatic expansion. Stage 3 is isothermal compression. Stage 4 is adiabatic compression. So these four constitutes Carnot cycle. So this is what exactly happens. First step is isothermal expansion step. Second step is adiabatic expansion. Third step is isothermal compression. Fourth step is adiabatic compression. So let us understand the construction of this Carnot engine or Carnot cycle. Now, first, he has taken three things actually. First thing is called source. Source means this base is conducting and a lot of heat energy is there here. That is called source. So TH is hot, high temperature. Next, here this is insulator. This is insulator. Okay. Next, this is sink. Sink is TC is cold temperature. So TH is greater than TC. So his construction is, you want to perform these four operations, that is isothermal expansion, adiabatic expansion, isothermal compression, adiabatic compression. These all you can do on these platforms, that is source, insulator, sink. So let us see. First one. Now just I'm going to explain, superficially. Now once as we get into the following slides, I'm going to give proper detailing. Isothermal expansion is done so on this source. Mind you, these are all insulated. These are all insulated only. Okay. So here you have a cylinder, you have a piston. Okay. On that weights will be there. Okay. And this is connected to a source. Okay. You may ask a question. Why you have to connect to the source? It's very simple. Isothermal, here temperature should remain constant. Okay. Expansion. Listen carefully. To do the expansion, work is done by the system or on the system?
By the system, sir.
By the system.
Work is done by the system, right? So, 1 second. So, work is done by the system. So, work is done by the system. Work is done by the system means what happens to internal energy?
Internal energy decrease.
Internal energy
Internal energy
decreases.
decreases.
That means temperature decreases. Temperature decreases, right? That's why but isothermal process means temperature should maintain constant.
Yes, sir.
Agreed. So
Yes, sir.
this is the source which gives, it is conducting, this base is conducting, right? So it is going to give what? The heat. It is going to give heat. The heat is called Q1. Okay, Q1. So heat is given. Agreed or not? Heat is given. Agreed or not? Why heat is given? To keep?
To
To maintain
the
temperature constant.
temperature.
Maintain constant
Temperature.
temperature. I hope you are clear about it. Now, so this first is isothermal expansion. Next, I want to do adiabatic expansion. I want to do adiabatic expansion. I keep this on insulator. Okay, because these are now adiabatic. Heat cannot be transferred. Do you agree or not?
Yes, sir.
Yes,
Heat
sir.
cannot be transferred. Because this is heat cannot be transferred on these walls. Okay, and here also heat cannot be transferred. Okay, now I already conveyed to you this is insulated. This is not conductor. This is not conductor. This is insulator only. Okay, only conducting part is this one only. The see back one. This is not conductor. Try to understand. This is insulator only. Only the down part is conducting. Are you following or not? Yeah. Same thing here also. Same thing only. Now, let us say it is adiabatic expansion, right?
Yes,
Now
sir.
tell me, in the adiabatic expansion, here, because all sides heat cannot be transferred. So what is zero? Transfer
Q
of
is
heat.
zero.
Heat transfer.
Delta Q 0.
Now naturally, now expansion should happen. When expansion should happen in adiabatic process, so what will happen? Can you tell me?
Pressure decreases.
So
Pressure
here
Temperature.
work done. Work is done by the system again.
The volume.
Yes, sir.
Work is done by the system again. Agreed or not?
Yes, sir.
Yes,
Initially
sir.
here the temperature is TH. Agreed? Here. T1. Let us take T1. Okay. Let us take T1. No problem. Now here work is done by the system means what happens to the internal energy?
Decreases.
Decreases.
Internal energy decrease. Temperature what happens? Temperature.
Decreases.
Increases.
Decreases.
Now you got temperature T2. Is it okay?
Yes, sir.
So
Yes,
can you
sir.
tell me temperature T1 is greater or T2 is greater?
T1 is
T1 is
T1 is
greater.
greater.
is good.
T1 is greater than T2.
T2.
Any problem so far?
No, sir.
No, sir.
Okay, fine. Next. Now let us see
Isothermal compression.
isothermal compression. Okay. Now isothermal compression, I'll be bringing again to the sink. Okay. I'll connect to the sink. Okay. Here you should do. Don't do on the source. Okay. Why I'll tell you. Listen. Now here. Now compression. Compression. Compression means work is done
On the system.
on the system.
On the system, sir.
Work is done on the system. So work is done on the system. When work is positive, see, internal energy delta E is equal to 0.
Increases.
Increases.
Yes. Here
Okay.
internal energy increases. temperature what happens?
Increases.
Increases. But the system is what here? Isothermal.
Isothermal compression.
Isothermal means temperature is
temperature
increasing.
should be
So you
constant.
throw the heat out. Whatever excess
Yes,
heat
sir.
is there, you throw. Are you following or not? Why you
Yes,
are
sir.
throwing the heat?
To maintain temperature constant.
To maintain temperature
Constant temperature.
So Q2, throw it out. Are you following? So here
sir.
Yes,
temperature
sir.
is maintained. Temperature is maintained at T1 or T2?
T2,
T2,
sir.
sir.
Very good. This is T2. What is this one here?
T2.
T2. What is this one here?
T1.
T1, sir.
T1. Very good. Any problem?
No, sir.
So, can
Yeah.
we say that there is no change in the temperature for this?
Yes, actually work is done on the system. When work is done on the system, what is happening here? Internal energy is increasing.
Yes, sir.
So
Yes, sir.
excess heat is there. Because you have to maintain the temperature constant. For example, here temperature is 200 degrees. Let us assume.
Yes,
But
sir.
what happens? But when work is done on the system, temperature is increased to 300. So to maintain the isothermal process, to maintain the constant temperature, 100 degrees, you throw it out as heat to the sink. Sink means
Okay, sir.
sink is surroundings, atmosphere. For example, when rail engine is going on, atmosphere is getting heat or not?
Yes, sir. Yes.
Yes, sir.
Surroundings is sink.
Yes,
following?
Okay, sir. Yes, sir. Thank you, sir.
So these 3 steps everybody has understood.
Yes, sir.
Yes, sir.
Yes, sir.
Fine. Next. Again, adiabatic compression. So source and
For
sink.
the last step, now my internet got a problem, sir. Can you
Okay.
explain the last step again? I cannot. Didn't listen.
Last
Net
step.
problem.
This step.
Yes. Sir.
Okay. This
Sink.
step is isothermal compression. Isothermal compression means work is done on the system.
System.
When work is done on the system, internal energy increases.
Increase.
But internal energy increases means temperature increases.
Temperature also increases.
So, but I require a constant temperature. So
Yes.
extra heat you throw it out to the sink to maintain
Okay.
constant temperature.
Okay. Sir.
So
Yes.
here when you connect to the hot source and the expansion work, internal energy decreases. That's why you take heat.
Yes, sir.
Yes.
Here work is done on the system, you throw it to the sink.
Yes, sir.
So to maintain constant temperature can be maintained. That is the
Maintain.
basic logic.
Yes,
Clear?
sir. Thank you, sir.
So now last step, adiabatic compression. Adiabatic compression, again I told you, anything adiabatic, where you have to do, which
Yes, sir.
platform you have to do?
Insulator plant.
Insulator.
Platform.
Insulator you have to do. You have to connect to the insulator. How he got the idea, Carnot, we don't know. So now here what happens? Listen carefully. Adiabatic compression, listen. Adiabatic expansion, what happens to the temperature?
Decreases, sir.
Decreases.
Very good. Temperature decreases in adiabatic expansion. Adiabatic expansion. Now, so far, listen carefully. This is T1. This is T2.
T2.
Agreed, na?
Yes, sir.
Yes, sir.
Now,
Sir.
listen carefully. This is also T2 only. Here it is there.
Yes,
Now, listen
sir.
Yes,
carefully.
sir.
Now, adiabatic compression. Adiabatic compression means work is done
On the system.
On the
on the system. So, internal energy,
Increases.
Increases.
temperature
Increases.
Increases.
increases. That's why, again, you get back your T1 temperature.
Yes, sir.
Yes.
Agreed or not? So, cycle is finished. Cycle is done. Agreed or not?
Yes, sir.
Yes, sir.
Have a look here first. So, can you see the insulation here?
Yes, sir.
Can
Yes,
you see
sir.
insulation here? This is insulation. Can you see the weights here? Weights.
Yes,
Yes,
sir.
sir.
Yeah. This is ideal gas. Okay. So, and this is conducting. 1 second. I'll write here for your sake. So, this is conducting. This is also conducting. This is insulator. Clear or not? So initially we have ideal gas has is at P1, V1. Pressure V1, pressure P1, volume V1. Now,
Yes, sir.
now it is brought here to the source. So what is the temperature here?
T1.
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 So I'll write the temperature here. So temperature is T1 here. T1. Okay.
Yes, sir.
Now, when it's brought here, what happens? Expansion takes place. Expansion takes place means what happens to the pressure?
They both change, sir. Pressure and
Change.
volume change.
Pressure increases or decreases?
Pressure
Decreases.
increases.
Pressure decreases.
Pressure
That means,
decreases and
see,
volume.
listen, how do you expand? This weight I'll remove. Okay. This weight I slowly remove. When I remove, what happens? This will expand, right? So pressure decreases. So P2 is greater or P1 is greater?
P1 is greater.
P1 is
P1,
greater,
sir.
sir.
That's why can you see here the graph also, which is greater, which is highest point?
P1, sir.
P1.
P1, sir.
Good. Next, volume. Expansion means volume is, which all volume is more?
So
VT is
volume V2 is more, sir.
This is
After
V in
expansion, it's
x-axis.
more.
So naturally V2 is more. Can you see here? Graph.
Yes, sir.
Pressure here in this case, pressure is more. Here volume is more. So you got a new situation. The new situation, what is the temperature?
T1, sir. Constant
T1,
temperature.
sir.
Can you see here T1?
Yes, sir.
Yes, sir.
Yeah. Yeah. Now, this is T1. So this is the first step. So arrow mark, can you see arrow mark? Expansion. Arrow mark. Everything is important. Clear or not? Now,
Yes, sir.
when you brought now adiabatic compression, adiabatic expansion, you connect to this here. When you connect to this here, completely insulated because this is insulated. So even it is conducting, if it is insulated, nothing will go. So heat will not go. Then what happens to the temperature?
Changes.
Increases.
Changes.
Isothermal
Increases.
expansion leads to cooling. So
Yes.
temperature T2 is less.
More.
Less than T1.
Yeah.
Yeah,
Less.
this is less than T1. Less than T1. Okay. Now, expansion means what? Volume, what happens?
Increases, sir.
Increases.
Increases.
Increases. So can you see here V3 x-axis
Yes, sir.
side
V3
increasing
is
or not?
greater than
Yes,
V2.
sir.
This point is
V3
here,
greater
this
than
point is
V2.
here. Can you see a volume change?
Yes, sir.
Yes, sir.
Yeah, this graph should be drawn properly. Now, pressure, what happens?
Pressure decreases, sir.
Further decreases. Huh? Pressure drops. Expansion means pressure drops. Agreed?
Yes.
Yes, sir.
So temperature is new temperature T2. So hope you understood so far. Now, adiabatic, no, expansion is done. Next, again, bring this here to the sink. Sit, make it to sit here. So then what happens? You have to do,
Isothermal compression.
Isothermal compression.
you have to add weights. You have to add weight.
Yes, sir. Yes, sir.
Okay,
Sir.
add weight here. Add weight. So when you add weight, what happens? There will be a
Volume.
It
compression.
will go
Volume
compression.
Volume, what happens? Volume.
Volume decreases, pressure
decreases and pressure increases, sir.
Now clearly you can see volume is decreasing. Volume is decreasing.
Yes, sir.
So temperature is maintained or not?
Yes,
Isothermal,
sir.
not?
Isothermal.
Yes, sir.
Temperature is
Temperature is
constant.
T2 only.
Yes,
Temperature
sir.
is T2
T2.
only. Okay. Pressure, what happens? Compression.
It
Pressure.
increases,
Pressure
sir.
increases.
Pressure
Increases.
increases. So here P4, can you see a pressure increase? Can you see a increase in pressure?
Yes, sir.
Yes,
Yes,
sir.
sir.
In volume clearly? Clear or not?
Yes, sir.
Yes, sir.
Sir.
Yeah. And the last step. Last step is adiabatic.
Compression.
Compression.
Now, one second. Here, isothermal case, when work is done on the system, internal energy increases because work is done on the system. So throw the heat out. So here, heat is thrown.
Yes, sir.
Here heat is given,
on
and
the
here heat is thrown. Agreed or not? Q2. This is Q1. Here heat is absorbed by the system. Heat is given here,
Yes, sir.
and here heat is thrown.
thrown out.
Thrown out.
Q2. This is Q1. Are you clear or not?
Yes, sir.
Now, last step adiabatic compression.
Compression.
Work is done on the system. When work is
Yes,
done
sir.
on the system, what happens to the internal energy?
Internal energy increases.
Increases.
Temperature
So
increases.
temperature T2 to T1. Again, you get your
T1.
T1 back.
Original temperature.
You got original back. So it is a cycle.
Sir, and pressure and volume also reaches to its initial position, sir.
Yeah,
Yes, sir.
you get back. Okay. So this is all about the Carnot cycle.
Sir, how much heat is taken, that much amount of heat is thrown out, sir. Exactly that.
No, it depends.
Okay.
So you can see here, work done is a what function? I'll tell you one thing.
Path function.
You asked a nice question. Work done and heat, both are path functions. Right?
Yes, sir.
Yes,
So
sir.
they're different. They're different. Right?
Yes, sir.
State functions will be same. Entropy is same. Entropy is
Okay.
zero. Cyclic
Yes,
process.
Yes,
Delta
sir.
H is
Entropy
zero.
zero.
Cyclic process.
Yes,
Internal
sir.
energy is zero. Cyclic
yes,
process.
cyclic process.
But work done and heat,
They are
they are,
not.
they are path functions.
Yes,
So
sir.
definitely it will be different, right? Path is different, right?
Yes, sir.
Now you can see W1 is the work done here. So can anybody tell me what is the work done? What do you write here? If you were to write the work done here.
Sir, NR T2 minus T1 by gamma minus 1, sir.
Gamma minus 1.
NRT is there or not?
Yes, sir.
NRT,
NRT ln
ln
V2 minus
ln
V2 by V1.
V2 by
V2
V1.
Yes.
You agree or not?
Yes, sir.
If you write the entropy,
Sir, it
entropy
is
is what?
negative.
Q by T. TT gets cancelled.
Yes, sir.
NR,
NR
ln
ln
V2
V2
by
by V1.
V1.
Sir,
Yeah,
the work done is negative, no, sir.
negative only. Negative only.
Yes.
Clear or not? Yeah.
Yes, sir.
Now, here what is the work done in adiabatic process?
Minus NR T2 minus T1 by gamma minus 1.
By gamma minus 1.
Gamma minus 1.
You can write this way also.
Yes, sir.
Yes, sir.
And what about the entropy? Adiabatic, 0.
Zeros cyclic process.
And here what you write? W3.
Sir, NRT ln V1 by V2.
Not T1. Yes, sir, that.
NRT ln, not V2. This is
V1 by V2, sir.
V1 by V2.
no, actually here volume is different, na? V3,
Sir,
yeah?
V3
V3,
and
V4,
V4,
eh?
sir.
V3,
Sir,
V4, na?
V3. Yes, sir. V3 by V4. I think.
V3 by
V3 by V4.
Yes,
Minus
sir.
I didn't write. So delta S will be how much? Same thing only.
Yes, sir. NR
NR
ln V4
ln
by V3.
V4 by V.
Okay. And what about here?
Delta is 0, sir. W equal to NCV T2 minus T.
Yes, sir.
Okay.
Yes, sir.
This gets cancelled. This work gets cancelled. W2 and W4 opposite sides.
Yes, sir.
Yes, sir.
Yes, sir.
Delta S becomes 0.
Yes, sir.
Entropy
Yes,
will be
sir.
0.
Cyclic
Totally
process.
delta entropy will be 0.
Yes, sir.
Understanding how to study
Yes, sir.
Yes, sir.
Carnot
Sir,
cycle.
sir, in adiabatic expansion, work done is negative, na, sir? Like minus NCV T2 minus T1.
Yeah.
Yes,
Yes,
sir.
sir.
Now you can see this is the first step. P1, V1, THR you can take TH also. Here source is kept here. Okay. Now this is what happens. This is adiabatic. Hope you understood this, right? So this is how, initially P1 V1, P2 V2, next P3 V3, adiabatic. Adiabatic expansion leads to cooling. TC it becomes. Next compression, same temperature, then adiabatic temperature increases. So this is the cycle. Now, so you can see here isothermal expansion, adiabatic expansion. So here heat is given in the isothermal expansion, and heat is taken out in the isothermal compression. So the sink, it is taken out in the isothermal compression, and heat is given from the source, so to the ideal gas, so in the isothermal expansion. Okay, I hope you are clear about this. So that's why Carnot engine is written, the cycle is written like this. Why the circle is given like this? I hope you understood, right?
Yes, sir.
So now listen carefully. Q1 and Q2. What is the work done? How much heat is converted into work? Q1 minus Q2 is W. So what is the
Yes,
efficiency? Efficiency.
One minus.
W by how much
Yes.
heat is converted into work?
Yes, sir.
How much heat is converted into work? So W is equal to how much? I explained already. Q1 minus Q2.
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 So Q1 minus Q2 by Q2. 1 minus Q2 by Q1. You can also write T2 by T1. Clear or not? You can also write
Yes.
T2 by
Yes, sir.
T1. Yeah. Now work done is cancelled now. These two, W2 and W4 are cancelled. These, 1 second.
Yes, sir.
Yes, sir. The both are
Here, you know very well. Q1 is equal to W1 because delta E is equal to 0 in isothermal process. Agree or
Yes.
not?
Sir. Yes, sir.
Yes,
So this is
sir.
the work done in isothermal process expansion.
Yes,
This is
sir.
the work done in isothermal compression.
Compression.
And this is the work done in adiabatic 2 and 4. 2 and 4 gets cancelled.
Yes,
I have
sir.
written here, I didn't write minus T2 minus T1. I have written here T1 minus
Yes,
T2.
sir.
Yes, sir.
Yes, sir.
Clear or not? So
Yes,
this is
sir.
the net work done. Because net work done will be arising from only isothermal compression and isothermal expansion. Agree or not?
Yes, sir.
Yes.
This is
Yes,
the net
sir.
work done. Am I clear or not?
Yes,
Yes.
sir.
Yes, sir.
sir.
So this is all about the Carnot cycle. Any doubts?
No, sir.
You have any doubts? Carnot cycle. And what you studied in physics, now you have more clarity?
Yes, sir.
Yes, sir.
Yeah, very good. Yeah. So all of you, please go through this Carnot cycle once and solve the numericals. Okay. And tomorrow I'll come up with third law of thermodynamics, that is Gibbs free energy. What is it? Gibbs free energy we'll discuss.
Gibbs free energy. Yes, sir.
And yeah, and some numericals also we'll discuss. So that's all for today. So I open the session for discussion. Any doubts?
Sir, I think it is not related, but what happens to the heat when the heat is absorbed by the heat sink, sir?
What happens when?
The heat is absorbed by the heat sink. To the heat energy which is absorbed by the heat sink.
Heat sink means surroundings, it will go away. Extra
Okay,
heat.
sir.
That's what is efficiency is not 100%.
Okay, sir. Yes, sir.
Okay.
Yes, sir.
Okay. Thanks for
Thank
bearing.
you.
Have a good day.
Sir.
Yeah, please.
Sir, insulated means there is no change in heat, no, sir.
Yes, it's insulated system. You can't exchange heat.
Yes, sir. Thank you, sir.
Yeah.
Here, network done is not considered. Network done is not dependent on the expansion, sir.
Pardon?
Network done is not dependent on expansion.
Net work done.
Sir is
Is
saying
not
that
dependent on
network done is not
compression.
dependent on expansion.
Work done. No, adiabatic compression and adiabatic expansion, that work gets cancelled. Isothermal work will be left out. That will be
Yes,
additive.
sir. It gets, that means we should not consider the both in network done.
Yeah, it is easy calculations. Yeah,
Sir?
yes, true.
Yes, sir.
Both adiabatic compression, no need to consider.
Yes, sir.
That gets cancelled. Yeah. Okay. Thanks for bearing. Have a good day.
Thank you,
Thank
sir.
Good evening.
Thank
Thank
you,
you, sir.
sir.
Thank you, sir.